Launch Logger Pro software by double-clicking on the desktop icon labeled Logger Pro. If the arrow icon near the center of the toolbar is grayed out, it means that the software is not recognizing the spectrophotometer. Unplug the spectrophotometer from the computer and plug it back into a different USB port. The arrow button should turn green and the screen should display a colored spectrum. A light within the spectrophotometer should illuminate once it is properly recognized by Logger Pro. Shown here is most of the glassware needed for the experiment, as well as the blue dye stock solution. There are 3 10 ml volumetric flasks with stoppers, a 2 ml and 5 ml volumetric pipette, and a 30 ml beaker. Prepare the pipettes by rinsing with stock solution. Prepare the volumetric flasks by rinsing with deionized water. Rinse the beaker with stock solution, as you will be pipetting from the beaker, not the stock bottle. At this point, you should reference the video for experiment 1 if you need to refamiliarize yourself with using a volumetric pipette and volumetric flask. With the glassware provided, you should be able to figure out how to create 3 dilute solutions that are 20%, 50%, and 70% of the concentration of the stock solution. Calculate and record the concentrations of your solutions. Be sure to use a Pasteur pipette and deionized water to fill your volumetric flask to the marks, since you're using a very small 10 ml volumetric flask, which is very easy to overflow. At this point, you should have your 3 solutions prepared. Be sure not to mix up your samples, although it should be obvious upon inspection to know which sample is most dilute and which is most concentrated. You will need to run 5 samples, a deionized water blank, the 20%, 50%, and 70% solutions, as well as the stock solution. Shown here is the cuvette which will hold your samples. It has 4 sides, 2 of which are smooth and 2 of which are ridged. Always hold the cuvette by the ridge side, as the spectrophotometer shines light through the smooth edges. Rinse the cuvette 3 times with deionized water, then fill the cuvette with water. It only needs to be roughly 70% full. Clean the smooth sides of the cuvette with Kim wipes, making sure that there is no excess liquid on the outside of the cuvette. And place the cuvette in the spectrophotometer with the smooth edges aligned with the white icons. Calibrate the spectrophotometer with the deionized water sample. Follow the instructions in your lab manual. Simply click on Experiment, Calibrate, and Spectrophotometer 1. Make sure to let the warm-up finish before you press Finish Calibration and then finally OK. Once this is completed, the SpectroVis has been zeroed using deionized water. Remove the cuvette and discard the water. Rinse the cuvette with stock dye solution. Fill the cuvette with stock dye solution and place the cuvette in the SpectroVis. Again, make sure that the cuvette is placed correctly in the SpectroVis with the smooth sides facing the white icons. Acquire the absorbance spectrum of the stock solution by pressing the spectrophotometer icon and then the absorbance versus wavelength icon. Then press OK. After a few seconds, the absorbance spectrum should appear on screen. The spectrum shows you the absorbance profile of the stock solution within the visible spectrum. Be sure to press the auto-scale icon to maximize visualization. Enter an appropriate title for your graph by right-clicking with the mouse and choosing Graph Options. There will be a space for you to enter your own title. Determine lambda max for the blue dye. This is the wavelength where the dye absorbs best. You can easily visualize this from your graph by placing the cursor at the highest peak. The wavelength and absorbance value can be seen just under where the X and Y axis meet. But you can also look through the absorbance data on the left and find the exact wavelength where the absorbance is highest. Remember, at this point, we are looking for the wavelength where the dye absorbs best, not the actual absorbance value. Click on the spectrometer icon and select Absorbance versus Concentration. make sure to select the wavelength that corresponds to your lambda max. The exact value for your lambda max may not be present on the list. It doesn't matter as long as you choose a wavelength within a nanometer or two of your lambda max. Rinse a cuvette with deionized water and fill it with deionized water and place it in the spectrophotometer. If the absorbance reading is not 0, then recalibrate the spectrophotometer. Once the absorbance of the blank is 0 or close to 0, some fluctuation is to be expected. Press the green Collect button, then press the Keep button and enter the concentration of your blank. Remember, we are collecting the absorbance for 5 samples. Do not press the red Stop button until all 5 samples have been collected. You are only pressing the Keep button after each sample. Be sure to press the Auto Scale button to ensure proper visualization of your data points. Empty the cuvette and rinse with the 20% solution. If the cuvette is not rinsed properly and some of the previous sample combines with the current sample, the concentration and therefore the absorbance reading will not be accurate. Again, be sure to place the cuvette in the spectrophotometer properly, taking care to notice the location of both the ridged and the smooth sides. Press Keep and enter the concentration of your sample. Be sure to enter the correct number. You may notice the red dot may appear in a strange location. Pressing Auto Scale should correct this. Empty the contents of your cuvette and repeat this procedure for the remaining samples. At this point, you should have what appears to be a linear relationship between absorbance and concentration. At this point, you may push the Stop button. Apply a curve fit to the data. This will not work if you have not pushed the Stop button yet. With your standard curve and curve fit data, you can calculate the concentration of an unknown sample as long as its absorbance lies within your standard curve. Prepare the cuvette as before and measure the absorbance of the unknown. You do not need to push Collect or Keep, simply read the absorbance above or below the data table on the left.